Hey, Steve.
Hey.
So in the last episode, we were talking about sort of like the companies that just throw AI at the end of their product and are trying to like jump on that trend. And one of the things we discussed is data and how it can't just like work magically. You can't just throw AI at data and expect it to work out some insights and results. It's all about structuring data. And we got some feedback, people asking questions about that specifically. So let's talk about that in more detail. So, where's the gap in people's knowledge? Because it seems like people think AI is best at managing data.
So that's probably a massive misconception. I mean, a lot of it would come out of, say, AWS sort of advertising AI analytics. But AI is really bad at analytics, especially all the new LLM stuff.
Yeah.
So what LLMs are good at is being the interface. So you're not a data expert, you're not an analytics expert. You might say, what day of the week is the office most busy?
Yeah.
And you need a bunch of structured data in the background that LLM can go and query. But it all has to be very well structured. The query interface is very well defined. Effectively, if you were an expert at data analytics with well-structured data and someone said, can you create a graph out of this well-structured data? An LLM could probably go do it.
Yep.
And I guess a good analogy is if you have a nice, well-structured spreadsheet, you might be able to query it and come up with some good insights. But if you had 30, they might be well-structured, but 30 disparate spreadsheets with different data, everything in different formats, you would struggle to try and make any connection between them.
Yeah, even like, just undefined timestamps with like an event and you don't know what that, those characters mean or how it relates to the timestamp.
And it could be a Unix timestamp versus a readable date.
Yeah.
And those things are very different. Well, it's harder for an AI to interpret the timestamp, even though a computer's good at interpreting that, and much easier to interpret a date.
Yeah. Where in fact, we as humans could probably look at unstructured data and try to put some clues together because we can think really abstractly or like compare it to something we know or do some further digging that like the large language models just, they're good at interface and guessing, what you're talking about, not analyzing data.
Yeah. And even if they get to the point where they can do that abstract stuff, which, realistically they might, they're still going to struggle just as much as any human would with that disparate data.
Yeah. Yeah, so it's interesting that this is the misconception because so many people are just assuming that AI is going to solve their data problems or it's the next step beyond dashboards, which I think it is in terms of interface, but dashboards require structured data to present in that format.
Exactly.
So anything in your dashboard, you could ask a large language model today because that data is already there and structured and meaningful. But how do we get beyond dashboards? I think it's is it like more structured data from so many different sources so the language models can cross-reference things that you haven't thrown into a dashboard?
Yes and no. I mean, mostly yes. So if you could structure everything identically, then potentially you could have one function. But realistically, you'd have a bunch of programmatic interfaces to the structured data that the AI model can use. And I mean, realistically, you want all your data to be in one sort of format, just because then you can cross-reference anything with anything else. But even then, you'd want interfaces to make it easy for the AI, because even if all the data is in the same format, it could all be unrelated data. So you've got to try and massage the data into relationships that matter and then provide the interfaces to the AI.
Yeah. Well, let's put this into some context of what we do. So we have an integration platform. So we have lots of things we're connected to that generate data, but that data is not useful, right, until we normalize it and they're coming from so many different types of systems. I think that key word you mentioned, like relationships between data.
Yeah.
Like how does the data coming from building access control integration relate to the security camera feed, and what do we do to make it comparable? And is normalization the right word for that context?
Yeah, normalization is definitely the right word. So effectively, we're taking the state of the world and then recording it in a time series database. So, so digital twin type stuff. Like we're not doing the big graphical 3D model or whatever, but digitally, it's a digital twin.
Yeah.
So we know the state of all the devices, sensors, whatnot out there.
By the way, that should be what you tell people at dinner parties. What do you do for a living? I take the state of the world,
digitize,
and I put it, and I normalize it.
Yeah. And then normalizing the data. So, you might have temperature sensors doing Fahrenheit, Celsius, and you want that all to be in a normalized format. Mm-hmm. So, I mean, we typically use Celsius just because it's the most common and easily
I can't
human.
think in anything but metric.
Yeah.
When I'm talking to US clients and I'm trying to give stories of workflows, I don't know what this means. Like, what is 100 degrees? I don't know.
Yeah. But I mean, even Celsius isn't the most scientifically accurate data point, but it's human readable and it's good enough. And we can customize it to actually convert to any temperature format we want. Mm-hmm. So the US clients, we actually do have saving everything in Fahrenheit. But it's that kind of thing. So everything has to be converted to the same units, because as soon as your units are different, it's impossible to do simple analytics on. You have to do post-processing before doing the comparison, so you just waste CPU. And then everything's effectively in a flat database. So like we take a few common data points, so timestamp, location, and a few other like effectively location. So as fine-grained location as we can. We try to put that into a geo database format. I can't remember what the format's called, but Google came up with it to effectively put anything on a map. So even like XY coordinates inside a building, the building's at this geolocation, so then we're converting that to a indexable geolocation.
Which is important in what we do, is what makes it a smart building or smart places project, rather than just like an integration platform for process automation. Like it's it can be that, and it is in some projects, but adding location is really important, so we know very specifically where events happened.
Yeah,
because often we want to know about analytics of space for future planning, for design, eventually generative design. If we have all this data that is normalized with location information, and we see the outcomes, the productivity outcomes for employees, or entertainment outcomes for live venues, whatever it may be, that can now be like used for design in the future.
Yeah,
and that's the sort of stuff with AI and data that I'm excited about. Not just like turning your dashboard into a query, like more about like what can we actually do with that data.
Yeah. So then we have the value, which is always a float. Technically, I think anything that matters, it's just a float. So whether it's an integer, a bool like true or false, a temperature, which usually is a float. So float's just like a number with a decimal point. So bool's 1.0 or 0.0. Integers just have the 0 added. .0, whatever. And then you've got your ranges. So everything is effectively stored as that value. And then there's a bunch of metadata around what it is. And we just have standards for meeting rooms and desks, bookable things and stuff like that. So the metadata is similar enough that you can then...
I guess that's the flexible bit, right? Like we may come into scenarios where the metadata is useful
Yeah.
so to get us, to solve a problem or to
Yeah. Well, you need to know like the desk ID.
Yeah.
And so in bookings, we just call it asset ID, and it works for desks, car parking spaces, whatever else there is. Lockers. Yeah. So you've got an asset ID, the value, like is it in use or not? Well, I mean, we store is it in use or not? Is it booked or not? Lots of data points.
Yeah.
And the metadata is almost enough to sort of understand the data. But if you're writing a query, you're still going to be like, I'm interested in desks or I'm interested in lockers. You're not really, and maybe you're interested in those two things, but you're not sort of interested in those two things in relation to the temperature of this zone potentially.
Yeah.
But all the data is effectively in a big spreadsheet.
Yeah.
That looks effectively the same for any data point, and then we have a query language that sits on top of that, and that's what the dashboard's built on.
Mm-hmm.
And then, like with LLMs, we're just writing nice functions for them to use to grab data. So whether it's usage, analytics for desks, capacity, I don't know. So you just provided as much dashboard information as you can.
Yeah.
And then it can grab the data it needs to answer your complex question.
And what's powerful about that immediately is it doesn't have to be necessarily in a dashboard. Like when let's say we design a dashboard for a client, we ask them what data is useful for them. We choose the visualization, like a pie graph versus, a line graph, whatever it is for the various things they want.
Yeah.
But then when we walk away, that's what they have. Where the interface with LLMs is it can access all that structured data and give you results even if we haven't put it in a dashboard. So that's I think where we can start getting insights and this flexibility where it doesn't have to be like similar to like just general large language model interfaces. You don't have to like hard code things.
Yeah, exactly. Yeah. And then it can merge things. So like it can look at capacity and temperature and maybe find some correlation, like more people in the building equals a hotter building. And that's something a human could do if they knew to look at these dashboards and find those two graphs and then work it out.
I mean, things people using dashboards effectively start doing as part of the reason for that dashboard existing in the first place. Like, we've done projects with dashboards on occupancy and energy usage. And that's an easy one to think, well, I'm going to look at these rooms that have higher occupancy. They should be the ones using the most energy. If there's a low occupancy, then we should see low energy consumption. And if that's wrong, then there's something going wrong.
Yeah.
And that's like the simple stuff dashboards are still good at because you can represent that visually and see that very easily. You don't have to think, I'm going to ask a prompt to, there's certain things that you want to glance at and see, everything's running effectively.
Yeah.
So there's still like a time and place for all of these traditional interfaces as well as the large language models. But I guess the thing in common is the structured data is like the starting point, the most important starting point.
100%.
Yeah.
You just can't throw data at like random spreadsheets and be like, work it out.
Yeah, exactly. Cool. I mean, that's all we wanted to talk about today. Roll the exit music. Do we have a theme song? No. I can.